There is a man who has spent over 30 years writing the software that runs most of the world's critical infrastructure, and he just shipped a warning inside the code that powers your bank, your hospital, your government servers, and the satellites orbiting the planet right now. He did not hold a press conference. He did not post a Twitter thread. He did not buy an ad. He merged 5,000 lines of code into the Linux kernel and let the implications speak for themselves. That man is Linus Torvalds, and what he just quietly told the world, wrapped inside the most important software update in years, is that quantum computing is no longer a future problem. It is a problem right now, and almost nobody who should be listening actually listened. To understand the weight of what Torvalds just did, you first need to understand who he is and why his decisions carry a kind of gravity that almost no other individual in the history of technology has ever possessed. In 1991, a 21-year-old Finnish computer science student named Linus Torvalds wrote the first version of the Linux kernel and released it for free to the world. What he could not have known then was that this piece of software would eventually become the invisible foundation beneath almost everything that matters in the modern digital world. Linux runs on more than 90% of the world's servers. Linux powers the cloud infrastructure behind Amazon, Google, Microsoft, and every major technology company on Earth. The International Space Station runs Linux. The stock exchange systems executing billions of dollars in trades every second run Linux. The Android operating system that runs on more than 3 billion smartphones is built on Linux. The supercomputers use to simulate nuclear weapons, model climate change, and discover new drugs run Linux. When you interact with virtually any piece of digital infrastructure at any scale, you are almost certainly interacting with something built on Linus Torvalds' creation. This is not hyperbole. This is simply the architectural reality of the modern technological world. When Linus Torvalds makes a decision about what goes into the Linux kernel, he is not making a product decision for a company. He is making an infrastructure decision for civilization. And in early 2026, he made one of the most consequential infrastructure decisions in years. He approved the merging of post-quantum cryptography into Linux 7.0. Like and subscribe right now, because the story of why that decision matters and who ignored the warning it contains is one of the most important technology stories of 2026 that almost nobody covered properly. Here is what was actually merged. Linux 7.0, released on April 12, 2026, included support for something called MLDSA, which stands for Module Lattice-Based Digital Signature Algorithm. This is a post-quantum cryptographic signature algorithm, one of the first algorithms formally standardized by the United States National Institute of Standards and Technology, specifically designed to resist attacks from quantum computers. In practice, what this means is that every time your computer loads a driver, a software module, or a piece of kernel code, it checks a digital signature to verify that the code has not been tampered with. Think of that signature as a wax seal on an envelope. It proves the envelope came from who it claims to come from and that nobody opened it in transit. The problem that Torvalds and the Linux kernel developers are responding to is this: the wax seals that Linux has used for decades, based on algorithms like RSA and elliptic curve cryptography, can be forged by a sufficiently powerful quantum computer, and once a quantum computer can forge those seals, an attacker could inject malicious code into kernel modules, bypass security verification, and compromise every system running Linux at the most fundamental level imaginable. Linux 7.0 added over 5,000 lines of new cryptographic code to begin replacing those forgeable seals with quantum-resistant ones. And in the same release, Torvalds approved the complete removal of SHA-1 module signing support, an older cryptographic standard that NIST had deprecated back in 2011 and that had already been shown to be vulnerable to practical attacks. The message in those two actions together, adding quantum resistance while removing the old broken standard, could not be more explicit. The quantum threat is real enough that the most widely deployed operating system on Earth is being rebuilt around it right now. But here is the detail that most people completely missed when this happened, and it reveals something important about the nature of the quantum threat and why the people who need to respond are not responding fast enough. The post-quantum cryptography in Linux 7.0 is not protecting against attacks that are happening today. Quantum computers powerful enough to break RSA and elliptic curve signatures do not yet exist in the form needed to attack real systems at scale. Experts estimate that threshold arrives somewhere between 2029 and 2035, depending on how quickly the hardware develops. So why is Torvalds shipping quantum-resistant cryptography now, years before the threat fully materializes? The answer is something called harvest now, decrypt later, and once you fully understand this concept, the urgency behind Torvalds' decision becomes impossible to dismiss. Here is the scenario. Right now, at this moment, state-level intelligence agencies and sophisticated criminal organizations are intercepting encrypted network traffic and storing it. Your medical records sent over an encrypted connection, classified government communications, corporate intellectual property, banking transactions, signed, software updates to critical infrastructure systems. All of this encrypted data is being collected and archived, not because it can be decrypted today, but because the attackers are patient. They know that classical encryption protecting this data today will be crackable by quantum computers within the decade. They are playing a long game. Stockpiling encrypted data the way a blackmailer stockpiles compromising photographs, waiting for the moment the lock can be picked. And by the time a quantum computer powerful enough to run Shear's algorithm against RSA encryption exists and is in the hands of a sophisticated attacker, all of that harvested data becomes suddenly, catastrophically decryptable. Every secret that traveled over an encrypted connection in the years before quantum computers arrived becomes an open book. The kernel modules signed with traditional algorithms that are being harvested today could theoretically be forged retroactively, meaning the security verification of software installed on critical systems could be undermined years from now, not today, but years from now, unless the transition to quantum-resistant signatures happens now. This is the threat that the Linux 7.0 kernel update is responding to, not the present, the near future that the data being collected today will be decrypted in. Like and subscribe, because the harvest is already underway and most organizations have no idea they are already behind. Now let us talk about who is not listening, because this is where the story gets genuinely alarming. The organizations that most need to respond to the warning embedded in Linux 7.0 are large enterprises. Governments, financial institutions, healthcare systems, and critical infrastructure operators, and the overwhelming majority of them are not moving anywhere near fast enough. A survey by D-Wave and Wakefield Research published in 2025 found that 81% of business leaders surveyed said they had reached the limit of what they could accomplish with classical computers for certain optimization problems. They understand the hardware side of quantum computing, at least in the abstract. But when it comes to the quantum threat to their security infrastructure, the response has been shockingly slow. The United States National Security Agency has already mandated quantum-resistant cryptography transitions for new national security system acquisitions starting in 2027. With a full quantum-safe migration required for national security systems by 2033, the National Institute of Standards and Technology has already finalized its first 3 post-quantum cryptography standards, including MLDSA, the exact algorithm now shipping inside the Linux kernel. The warning signs from every authoritative source that exists on this topic are pointing in the same direction. Transition now, do not wait. The window is open, and yet, as of 2026, no enterprise Linux distribution has achieved full FIPS 140-3, validated post-quantum cryptography, not Red Hat, not Oracle. Not any of them. The engineering work is being done, but it is not done yet, and the validation process alone takes over a year once the engineering is complete. The organizations deploying infrastructure decisions in 2026 are determining what security posture they will actually have in 2028 and 2029. Precisely. The years when the quantum threat starts becoming concrete rather than theoretical. The deeper problem is a failure of imagination that is almost universal among non-technical executives and policymakers when most people hear about quantum computing threats. They think about it the way they think about asteroid impacts or nuclear war, something terrible that could theoretically happen, but that feels sufficiently abstract and distant to not require urgent action. The harvest now, decrypt later reality obliterates that comfortable distance. The attack is not in the future. The collection phase of the attack is happening right now. While every organization that has not yet transitioned to post-quantum cryptography believes itself to be secure, the data being harvested today includes information that will still be sensitive 10 years from now. Medical records, legal communications, intellectual property, national security intelligence, military communications. The organizations that are not acting now are not failing to protect themselves from a future threat. They are failing to protect data they believe is already protected. That is a profoundly different kind of failure, and it is the kind that does not come with a warning moment. When a quantum computer eventually breaks the encryption on all that harvested data, the breach will not look like a breach. It will look like a slow, invisible hemorrhage of secrets that had already left the building years before anyone noticed. This is what Linus Torvalds understood when he approved the quantum-resistant updates. To Linux 7.0, he did not need a press conference. He did not need to make an announcement. In the culture of open source development, the code speaks, and what the code of Linux 7.0 says in 5,000 lines of post-quantum cryptographic implementation is that the threat is real, the timeline is short, and the infrastructure of the world needs to be rebuilt now rather than later. Torvalds has seen this pattern before. When the Meltdown Inspector CPU security vulnerabilities were discovered in 2018, he was blunt in his assessment that the flaws came from engineers who did not think carefully enough about the long-term security implications of design shortcuts. He said at the time that people knew. Speculative execution carried risks but chose not to fully reckon with those risks, and that problem became baked into virtually every modern processor on the planet. The quantum cryptography situation has the same structure. The risk has been known for decades. Shear's algorithm, which is the quantum algorithm that breaks RSA encryption, was published in 1994. For over 30 years. The cryptographic and scientific communities have known that RSA and elliptic curve cryptography would be vulnerable to quantum attack, and for over 30 years, the overwhelming organizational response has been to treat quantum computers as a sufficiently far-away problem that it could safely be deferred. That deferral is now ending, and the Linux kernel is one of the most visible signals that the reckoning has arrived. Hit that like and subscribe button because we are talking about the security of infrastructure that every person on this planet depends on, and most of them have no idea this conversation is even happening. What makes the Linux 7.0 quantum update particularly interesting is not just that it happened, but how it happened. The post-quantum cryptography work in the Linux kernel was not a top-down mandate from a government or a corporate executive. It emerged from the open source community, from kernel developers and cryptography experts who work on the kernel because they genuinely care about the quality and security of software that the world depends on. Eric Biggers, a Linux cryptography expert at Google, submitted proof of concept patches for post-quantum key exchange algorithms. The DebConf 25 conference in 2025 featured a dedicated talk titled Rethinking Cryptography in the Linux Kernel, where developers outlined a comprehensive roadmap for integrating post-quantum cryptography across encrypted file systems, VPN implementations, kernel module signing, firmware verification, and network authentication systems. This work is methodical, rigorous, and proceeding according to a plan that reflects a deep understanding of the threat. The MLDSA signing support in Linux 7.0 is explicitly described by the developers themselves as the first use case in the kernel, with other uses of RSA and ECTSA signatures throughout the kernel expected to eventually follow. The TELS stack, the network protocols, the authentication systems. The full roadmap of replacing every classical cryptographic signature with a quantum-resistant one is long and will take years to complete, which is precisely why it needs to be proceeding with urgency now. Red Hat, which distributes Linux to enterprises at a massive commercial scale, has been tracking this work closely. In May 2026, Red Hat announced that its enterprise Linux 10.2 and 9.8 releases were integrating NIST standardized post-quantum cryptography, explicitly framing this as a response to quantum threats, and the harvest now decrypt later attack vector. Red Hat's vice president described the challenge as a balancing act between the speed of AI innovation and the rigors of enterprise security. CIQ, the company behind the commercially supported version of Rocky Linux, went even further in the candor of its public statements, saying that organizations making platform decisions in 2026 are determining what is actually deployable in 2028 and 2029, and that the organizations doing planning work in 2026 are the ones who will not be panicking in 2030 when the timelines start compressing. That sentence should be printed and placed on the desk of every chief information security officer in the world. Because the window between when quantum computers become capable of breaking current encryption and when organizations complete their migration to quantum-resistant cryptography is the most dangerous period in the history of digital security, and that window could be years wide. The scale of what needs to change to achieve genuine quantum resilience across the world's digital infrastructure is genuinely staggering. The Linux kernel is a good starting point, but it is one piece of an enormous puzzle. Every piece of software that uses RSA or elliptic curve cryptography for authentication, for signing, for key exchange, needs to be updated. Every hardware device with embedded cryptographic keys needs to be assessed. Every certificate authority, every VPN implementation, every secure boot chain, every encrypted messaging application, every banking system, every healthcare network, every government database, every satellite communication link needs to transition to post-quantum algorithms, and many of these systems cannot simply be patched with a software update. Some of them require hardware replacement. Some of them require protocol changes that affect every device that communicates with them. The ATM in your local bank branch runs firmware that was probably signed with RSA. The router managing your home internet connection is almost certainly using elliptic curve Diffie-Hellman for key exchange. The smart card in your passport, the chip in your credit card, the security module in your car's connected systems. All of these use classical cryptography that quantum computers will eventually break. The transition away from all of it at global scale is a process that will take a decade even if everyone starts immediately, and most organizations have not started yet. What Linus Torvalds shipped in Linux 7.0 is the opening move of that transition for the software layer that most of the world's digital infrastructure runs on. He did it without drama, without a keynote, without a press release. He did it by approving the code, merging the patches, and releasing the kernel on April 12, 2026, in an era of technology announcements designed for maximum media impact. It was a conspicuously quiet revolution. The people who understand what it means are moving. The people who do not understand what it means are waiting. And the difference between those two groups in the years ahead may be the difference between organizations that navigate the quantum transition smoothly and organizations that find themselves on the wrong side of one of the largest security failures in history when the quantum computers that are already being built today reach the capability needed to decrypt the data that is already being collected today. Hit that like and subscribe button, because Linus Torvalds just warned us. The code does not lie. The question is whether anyone beyond the kernel developers' mailing list is going to listen before it is too late. There is one more dimension to this story that deserves full attention, and it is one that goes beyond the technical details of cryptographic algorithms and kernel patches. It is the question of what it means that the most important security update in decades to the world's most critical software infrastructure came not from a government mandate, not from a corporate boardroom, Not from a regulatory body, but from a community of volunteer developers who cared enough about the future to do the work that needed to be done before anyone was asking for it. The open source model of software development has always been dismissed by certain corners of the technology industry as chaotic, leaderless, and unreliable. What Linux 7.0 demonstrates is exactly the opposite. The kernel developers who spent months writing, reviewing, testing, and merging 5,000 lines of post-quantum cryptographic code did so because they understood the threat and understood that someone needed to act. They are not waiting for permission. They are not waiting for a mandate. They are building the quantum-resistant future of digital infrastructure, one carefully reviewed patch at a time, on a volunteer basis, for the benefit of the 7 billion people whose lives depend in some way on the software they maintain. And Linus Torvalds, the man who has guided this community for over 3 decades with his characteristic blend of technical brilliance and zero tolerance for anything that makes the code worse, approved their work and shipped it to the world in the form of Linux 7.0. That is what a warning looks like when it comes from an engineer rather than a politician. Not a speech, not a headline, not a threat assessment document. 5,000 lines of carefully written code, silently deployed to billions of devices, carrying the message that the people who actually understand what is coming have decided that waiting is no longer acceptable. Whether the rest of the world chooses to hear that message in time is the most important open question in technology. Security today. Consider the specific devices and systems that Linux 7.0 will eventually protect as the post-quantum transition works its way through the ecosystem. Ubuntu 26.04 else and Fedora 44 already ship with Linux 7.0 as their default kernel, meaning the update is already running in production on development machines, cloud servers, and workstations around the world. Red Hat Enterprise Linux 10 and its downstream equivalents are tracking it for enterprise deployment. The Android devices of over 3 billion users run a Linux kernel, and as the mobile ecosystem catches up with the kernel's post-quantum work, those devices will eventually carry quantum-resistant security protections at the operating system level. The cloud servers running your streaming services, your email, your financial applications, all of them run Linux, and all of them will need to complete the cryptographic migration that Linux 7.0 started. The work is not finished, not remotely, MLDSA, for module signing is explicitly the first use case. With the TELS stack, network protocols, and authentication systems still ahead on the roadmap. But the direction is set. The standard is chosen, the code is being written, and the man who has final say over what goes into the software that runs the world has made his position unambiguous. He is preparing for the quantum future because the alternative, waiting until quantum computers are powerful enough to make the urgency undeniable, is the kind of thinking that turned Meltdown and Spectre from preventable design flaws into decade-long security nightmares. Torvalds has been here before. He knows what late looks like, and this time he chose not to be late.